Hello and welcome back to SQL Interview Preparation Series. While you apply for your Data Analyst, Backend Developer or Data Engineer role, SQL questions are very important. Here is our Chapter 4 series, SQL Interview Preparation. So we will cover with this SQL Interview Preparation Series. You can crack your next interview with 100% confidence. Let's start the preparation of Chapter 4. By the end of this video, with all the hands-on examples, you will have a better understanding of SQL core concepts. So in this video, we will be using DBeaver for execution of SQL queries, and we will be working on Docker image for SQL Server for practicing purposes. As you see here, we have already created employee and department tables for the execution purposes. I'll post the link to the installation guide of DBeaver and Docker image for SQL Server in the description below. If you have any doubts, please do comment. I am happy to help. So this is the Docker image. With the Docker image executed, we can connect to that particular SQL Server from DBeaver, and we can do create, insert, update operations as we have done in our previous videos, chapter 1, 2, and 3. So let's move to our first question. What is the difference between inner join and outer join? The key difference is the results that both the joins are fetching. So inner join retrieves only the rows that have match from both the sides. If there is no match, then those records are excluded. Let's see a Venn diagram. Like here, inner join will fetch only the common intersection apart from both left and right side tables, which is highlighted in blue color. Let's practically execute and see inner join and outer join. So let's say we have employee table with these 10 records, employee ID, first name, last name, and department ID, and departments table, department ID and department name. Let's open DBeaver and execute a SQL script by opening a new SQL script editor. Let's start writing. Select first name from employee table. We will give ES alias for employee table. So E dot first name from employee. We have table name employees. So employees E, and we will add another column department name from departments table D. We have to join. First we will use inner join. Which table we are inner joining with employees? Departments. The beauty of DBeaver is it will give the suggestions when you are typing in the departments D, and we have to write a condition on inner join requires on condition E dot department ID equal to D dot. It suggests the column names from the departments table, so you can just select department ID. So now let's execute. Before execution, let's give the alias names for each column, name and department, so it is easier to understand from the results. So now we have 8 records from department table and 10 records from employees table. So when we execute inner join on department ID, let's zoom out for better visibility of the query and execute. Hit on the execute. So now it fetched within seconds the results, which only has matches from the both the tables. So only 8 records have returned. If you observe from employee table, you only have 10 records, among which 2 employees, Daniel and employee. 5th employee also have department ID as null, so those are not visible here. Apart from that, other all employees are included. From department tables, if you see, all departments are included because every department is having an employee from employee table. So common data has been fetched as part of inner join. Like we highlight here, human resources has 1 employee, engineering department has 2 employees. Both of the records has been shown in the result set. Likewise, if you see marketing, finance, support, transport, healthcare and automotive, all the employees attached to that department are listed in the result set with inner join. So that is about inner join. Let's move to outer join. What is outer join? It fetches all the records from both the tables irrespective of matches. When you talk about outer join, we have 3 types of outer joins: left outer join, right outer join, full outer join. So here are Venn diagrams. So you can understand better about these 3 types. Let's start with left outer join. It allows from the left tables matching rows from the right with unmatched rows in the right will be nulls, like we are highlighting here. What is right outer join? All rows from the right side will be shown and unmatched from the left will be filled with nulls. And then let's move to full outer join. So it will give all the records from both the tables. Unmatched will be nulls. Let's now see the execution of both the types inner and outer join. We have already seen inner join. Let's see queries for both the types. What it fetches as a result. So example for inner join we have already seen. Full outer join, we are joining on department ID from both the tables. With full outer join, employees without a valid department and departments without valid employees will also appear with null values wherever it is applicable. Let's open DBeaver again and execute a query. We have seen inner join already and we have understood it fetches only matched rows from both the tables and retrieves as a result set. Let's now move to a new SQL editor script. Let's start right. Select from employee we will fetch first name, b dot first name. By now you must be very handy writing queries like this, and we will fetch the department name from the departments table D. E and D are nothing but alias names for employees table E and departments table. So we will write a full outer join. We have to write a on condition full outer join on departments D. When you are typing, it will give you suggestions. You will have to utilize whatever is necessary. If it is not necessary, just escape to avoid that suggestion. So on E dot department ID equal to D dot department ID, you just choose the column names when you are typing. Just execute full outer join and see the result set for the query. You can hit on execute SQL script. So it fetches all the records and nulls wherever it is applicable. If you see here, There are few rows with nulls as department name and first name as nulls for the last row because that particular department does not have an employee. So it fetches the department name but null for employee first name. That is how full outer join works. When you are highlighting this one, employee has fetched with human resources department 1 and engineering also been fetched because those have matches. Likewise, finance and even the null value department from employees. So that is about full outer join. So next question is how cross join works and when it should be used. Cross join is simply a Cartesian product of two tables. Like here, we have a select query. We only have cross join on departments. We don't have any on condition for cross join. If you have 10 records from employee and 8 records on departments, 10 into 8, 80 records will be returned as a result set. Let's say interesting conversation here to understand the cross join.
Hello.
Yeah.
So this is about cross join. So we have detailed understanding of the query for cross join here. We have aliases, join type, and we have row count from employee 10, departments 5. So total rows are fetched are 50 from employees, 50 from departments. So that is a Cartesian product. So there are few cons and pros. Let's see what it is. First of all, we will see the pros. For data analytics purpose, to fetch the Cartesian product, we will be using cross join to fetch the huge data. And cons are performance and others as shown here. You will be very cautious when you are using Cartesian product because cross join gives a Cartesian products of two tables, which is basically m by n in size. Let's try to execute a query on cross join. It must fetch every record from employee and every record from departments table. So let's write a SQL query. Select need our first name. By now you will be very handy writing this query. D.department. We are writing a cross join, so we don't have a on condition from. So we have written already. Select E first name, D department name from employees alias E cross join departments. D we don't have any on condition because it is a cross join. Let's choose wisely from the suggestions. If it is giving wrong suggestions, you need to be very careful. We need to choose the right suggestion from this. We don't have a on condition. You can give a semicolon and select and hit on first option, execute, or second option, or third option as well. So when you execute, it immediately give you use data result set. So we are seeing a scroll bar here like before. We don't have those many results. If you see, it has 80 results total because we have 8 departments and 10 employees. So 8 by 10 is 8 into 10 is 80 employees. 80 result set. So every record from employee has been present. Every record from department is also present. You can see by sorting first name. If you see each department, each employee has been repeated the records that is present in departments. Employee 1 repeated for 8 times because we have 8 departments. Likewise, all 10 employees have been repeated for 8 times. So every employee has department attached irrespective of the matching. This is nothing but cross join. If it is as it is only 10 and 8 records from both the tables, so you have first got 80. Think about having lakhs of records. You will end up reducing the performance by doing a Cartesian product on lakhs of tables. We can sort by department name as well to see the departments are also repeated the number of times, the number of records in a employee table. I have to disable first sorting of first column and then we'll be able to sort on second column. So now if you see, so all department names have been repeated 10 times. And so that's about Cartesian product, cross join. You need to be very careful and you need to understand when to use cross join. Let's move to next question. What are correlated subqueries and how do they differ from regular subqueries? First of all, let us see the definition of a correlated subquery. It depends on the outer query, access outer query data, potential performance impact for this correlated subqueries. Correlated subquery is a subquery that depends on the outer query for its values. It is evaluated once for each row processed by the outer query, unlike a regular subquery that is evaluated only once. So here is an example of correlated subquery on employees and departments table. So in this, the inner query depends on the department ID of outer select query. So it becomes a correlated subquery. Here are the steps involved in execution of correlated subquery. So outer query is very important in correlated subquery. Mostly depends on outer query. Access to outer query inside subquery is possible. Like other subqueries are independent. They are not independent on outer query access and they are very performance oriented compared to correlated subquery. And regular, if you see regular select, if you say do first name salary from employee table and write a where condition where salary greater than a subquery where salary subquery fetches average salary from employees again, then that subquery doesn't depend on the outer query. That is a regular subquery. Like here we are seeing the correlated subquery. Select first name salary from employees where salary greater than this is dependent on the outer query's current value. That is what the department is being matched here. Let's now execute and see to better understand about correlated subquery. So here is the correlated subquery. So I have written select query and just hit on the execute. So it fetches all these employees with salary above average salary from their particular department. If you go on view employees table, it has these many records. And if you see the first, it has salary. And let me try to edit these records to fetch some output to understand better about correlated subqueries. I'm just trying to edit and add few more rows here. So we'll see more records from each department. That is what expected when we are writing a query with a comparison. So we will understand whether those salaries are greater than average salary from that particular department or not. So you also can add records like this, and I'm just giving the sequential numbers for employee IDs. Just when you are doing this edit, you will need to save this before closing it. Then only it will be updated to the employee. Otherwise, it will be in incomplete state. I've added all employee names, salaries. So now we have new records. So now, we have to save this to update the employees table. So we have new records so that it will be showing multiple records. Let's go back to the subquery we have written. So here we have to see more number of records. So employees with above average salary. If you calculate for each department, the shown employees are with more than average salary. Let me also add department name so it will be more clear from which department that particular employee has been returned here in the result set. For more clarity, just try to add it and join the departments table. We'll do a left join. So that is about department name and execute. Oh, what is the error? Let me see. This is giving an error here. It's giving some error. Let me see what it is. Does need a department table. So let me remove that because we have department name already. We will print department ID. We will not make it complicated. We will just see which department ID. So we don't need to do any joins. We will only work on required correlated subquery. So now it has returned the department IDs. If you see from which department, which employee has the above average salary. So this is how. So it is giving those values. The department ID, if you see, it is fetched from the outer query. That means that subquery is depending on the outer query on the current record when it is executing. That's about correlated subqueries. This is how we have new departments after adding this like this. So that is how correlated subquery works. Next question is, how does SQL handle null values in joins on? How it is different while handling with nulls. So in SQL, what happens when you are handling nulls? You mainly need to understand how it is different in different joins. And as we have the question here, how it is How do you handle it? Joins and comparisons. So in SQL, null represents unknown or missing value. If there is a no match, it will give null. When performing joins or comparisons, when we are doing any join or comparison, we have to be very careful. When we are using joins, if one of the join column has null value, those rows won't match unless using outer join, because outer join fetches every record from both the tables. Comparisons, direct comparisons with nulls using equal to, not equal to won't work. We will try executing this. You must use is null, is not null. So example queries are here. How do you handle nulls is what we need to practice. Let's open DBeaver, and here we have nulls in department ID. Let's do some modification. So what is handling? Nulls. Let's write a select query. Select first name from employee table e dot first name, department name from departments table, so this is join conditions, join case, handling null values. So department, so on we will do same. E dot department ID equal to d dot department ID. So let's see how it returns the null value. So we had department IDs nulls. So it has returned department names also nulls because we used left join. Because the values are nulls, it returns nulls. If you say in case of a left join, if you say equal to null and execute the query, it did not return anything. That means it is not working. If you say is null, it has returned the null. So it is working only. Is null, is not null, will work. Let's try not equal to. It also not works with join condition. If you replace with is not null, it must fetch the results without nulls. These are all the records without nulls. So in join, we need to use only is null, is not null. So these are the two records. It's a null and department ID and department name has been fetched. Let's see inner join. We are saying not null. It is working. If you do not equal to null, it is not working. So outer join. So join case we have to use is null, is not null. For outer join, it is giving some error. We will do a full outer, left outer or full outer join because we don't have outer, we have left outer, right outer or full outer. That is what the error was. Left outer, full outer. Let's try. It works with is not null, is null, but not equal to or not equal to. So that you need to remember. The interviewer must ask, how do you write a full outer join with comparison like department ID is not equal to null. He must specifically mention not equal to. Because it doesn't work, you must say not equal to doesn't work with full outer join, and you must specify where condition with department ID is null or department ID is not null. So that is about handling nulls. So we have observed inner join failed with null also. So inner join, left join doesn't work with not null, is null also. Inner join doesn't work, left join worked, and right join did not work. Let's try to note it out. Note it down here. So you will go through again. So full outer join, let's execute and see. It worked. So left full outer worked. That means a right and inner join will fail not only with equal to not equal to, is null, is not null also will not work with right and inner joins. But they work with left join, full outer join. This is what you have to remember regarding handling null values. Let's move to next. Next. Next is what is window function and how it is different from group by. So a window function performs calculations across a set of table. So we already know some of the window functions: rank, row number. There are many more other. Let's see how it is different from group by. A window function performs calculation across a set of table rows related to the current row without collapsing rows into groups like group by. In group by, what it does, it groups a set of rows based on a conditions, and it allows you to perform operations like running totals, ranking, and moving averages. So like here we have a select query with rank over partition by. This is the syntax of window function as rank from employees. So this rank function assigns a rank to each employee within the department without grouping or collapsing. This is how window function works: running totals, ranking, moving averages. It can also be calculated, and this is useful for enhanced data analysis. Let's now see pictorial representation of how a window function in select query works, and also see the execution in DBeaver. So window functions, we have a over class, we have window function of orgs, and we have partition by class. Within over, we have a partition by class, and partition by column 1, column 2, column 3, and so on. And we have order by column 1 ascending, column 2 descending. This is a syntax for window function. If you see the flowchart also, we have the same mention. After partition by, highlighted in orange color, we have order by, ordered rows, unordered rows. If you have ordered by, ordered rows we will fetch, unordered by, unordered rows. And rows or range from class if you mention. So defined window frame will be fetched, or default window frame will be used. Now apply this window function on the result set to see the result. This is how window function syntax is. We have some rank sum average row number. So let's write a query using window function. We will select first name, department ID, salary from employee table. We will only use employee table for now without complicating because we need to understand the function. So we have salary and we want to fetch salary rank. How do we fetch it? In place of the salary rank, let me write a rank window function. Arguments are empty over within parentheses. I will mention a partition by class, partition by how I will do department ID from employee table because I need to give a rank of salary within the department. So partition by department ID and let me give this alias name so that I can even give order by salary because ranking has to be ordered by salary descending because I wanted to fetch first salary as highest salary. So I will give descending order. Otherwise, it will get ascending lowest salary as rank 1. So I must specify order by class to get the expected rank for salaries. Order by salary from employees table and let me put it in a proper structure. Okay. Now as I wanted to fetch it as salary rank. So let me give a name, alias name to it, salary rank. So we can understand it better from the results. Otherwise, it will print the entire script rank over partition by and everything as column name heading. So I just mentioned salary rank as alias for this entire thing from employees. I don't need to give a alias for employees because I am using only one table. Just hit on execute and see the results. It has given a new column for each employee with a respective rank from the department. Null has 1 and 2, 1 has 1 department ID, 2 has 2 record 1 and 2 ranks. If you see 10,000 is the highest from department 2, $4,000 is the second highest salary, which is the last one. So, and then third has 3 records 1 and 2, 3. 55,000 is the highest, 40,000 is second, and the next third salary. 4 department has 3 salaries ordered by descending order ranking, which is correct. Again, 5 has 3 records. Again, 6 has 2 records. So 1 and 2 ranking. If it doesn't have any records, it will give only one rank. That is how window function to fetch the ranking works. Let us quickly move to another example and see a total salary using the window function sum. Let us sum salary from department. First name and then department ID, salary, and I will do a moving sum. So sum of salary over partition by, I have to do a partition by department ID. So department ID from employees table and order by salary. As I can do a just restructuring it and giving the alias name. We have not mentioned the salary order. Just give it running sum of the salary, running total of the salary. This is nothing but moving salary from current record to next record. From which table employees? I don't need to specify alias. It has to be executed now. Let's see the new row, the new column, ranking, moving total. So if you see from null, first record is 11 and 11 plus 30 is 41, and then department 1 has only 1, 2 has 4,000, 4,000 plus 10,000, 14, 20,000, so like that. Third also has moving salary sums. 4 has 25, 1 lakh 25, 3 lakh 25. 5 has 315, 15 plus 70, 80, 85, and 85 plus 2 is equal to 1 lakh 74,000. So that is salary. If I specify, if I change sum to max, what we will get? Max of salary from, I have to rename the alias, max salary in the department. You have to name the meaningful column name so it is better understandable. So if you see for each department, max salary from first row it has given max salary 30, second also it gave 30, because in that particular department 30 is max, and first 12 only one record, and second it has 10,000 as max, third it has 55k, and 4 2 lakhs 582, 6 it has its respective highest salaries. That's about those functions max. If you try to replace average and adjust the names accordingly, average salary from the department. So it has to add a new column, average salary in the department for each employee record. Hit on execute and see average. Like before we have seen max, now it is average salary. You can compare and see for each employee it has added average salary in that department. We can change. Now we will see a preceding, and so it must do order by salary and then rows between one preceding and one following. Moving average. We will be finding how do we find moving average using average, like using order by salary rows between one preceding and one following. If we hit and execute, it didn't execute. Let me see what is the error it is saying. Let me restructure it properly. Salary rows. And what is the error? Preceding is spelling mistake. Yes, preceding is the spelling mistake. Let me execute it and execute and see the results. So now if you see department ID 2 has that particular moving average, means it will calculate average, and based on which condition, preceding and the next record. If you see the second moving is like it displayed here. So you can try comparing each value. How does it fetch the moving average? from preceding to following. That's about window functions. And you can understand from this window function flow diagram how it executes. Partition by class, order by class, and in moving we have even added a rows. We also can use range class also. So based on the classes available, it will fetch the records. Let's move to next question. What are indexes and how can they affect query performance? You can read the definition here. An index generally improves the speed of the data retrieval by providing quick access paths to table rows. However, indexes also require additional storage. We have to understand how to create, how to drop an index, and how to use an index after creating it. Due to maintenance overhead, we will use without indexes generally, but for particular cases like search, binary tree indexes, unique indexes, or full text indexes can be used. Creating an index can be done with create index, index column name on table name of the column name. And then we can use that particular index when you are doing a select query with where condition salary greater than 50,000. It will first look into that index for all those indexed salaries which has above salary 50,000. They will be fetched quickly because they are located from the index table without scanning the entire table. You can understand how these three types of indexing work from this diagram. So we have full text, B-tree indexes, and unique indexes. It will differ in storage overhead, maintenance overhead, speed, improvements. Let's now see how to create an index. Like we have this index, create index. The name of the index, this is not the index. This is not the column from the table, but name that we are giving to that index column on employees salary. Normally we give idx underscore as a prefix, so it will be easily understandable. Then when I hit an enter, it has created successfully the index and it must show when we are viewing the structure of the employee table. When you try to open the indexes of that employees table, it must be visible idx underscore salary for salary column. So that's how simply you create index for salary. You can create even index salary on employees and then select SPH help index. Employees will select and show you the index. We have created two indexes, so those two are we have created IDX salary, so that particular index has been visible. Now how to use this index created? Let's start from employees where salary greater than 50,000. If you hit enter, execute that particular selected query, it will fetch all the salaried employees above 50,000 only. It is showing very lesser time. If you compare without that salary greater than condition 50,000 condition, before index was created and after index created, it will be very minimal because our database is very less in size. If you have trillions of records, then indexed table query performance will be much faster comparing to non-indexed tables. Let me drop the created index. How do we do? Drop index column from the table employees. Let me try to execute and see why we are doing it, to understand how to drop, and not only that, to even see the difference between non-indexed table query performance with where condition and indexed. So if you notice, it will be very minimal because as we have already discussed, we have very less data on our database. It depends on the database size. If you have gigabytes of or terabytes of data in your database, then you will see visible difference in both the cases. We can again create and we can again execute. See, there is a varying difference within fraction of seconds. You can see the number which is much faster comparing to previous. That's about creating and using and dropping index queries. It is giving some error while I try to it is create a unique index. You can create even unique index like this from the DBeaver, and not only DBeaver, other editors also will have the similar options to create unique index and normal indexes. So we have created index and unique index. Let us see. If you see create unique index, it just added unique in front of the index. But still it is giving some error. Execute and see it has created. Irrespective of the error, it created the unique index. Employee ID. Whenever we are using a primary key, then only we can create a unique index because that has to be unique. You can try creating other unique indexes, it will give error, and you can understand how unique index is different from normal index. You can even combine two columns to create an index, which is composite index. And we are searching through names of the employees, as we have first name and last name, we can combine those two columns as composite index employee name, and it can be later used to filter the results by name. Here we are doing index name and salary for understanding. We are giving a last name and salary as composite index. Just giving this syntax. There is no need of additional any keyword like composite. It just creates a composite index. And we are doing with two columns. So this created a composite index. And you know how to use this in your select query. Try to execute and see how their performances are different. That's about creating indexes. Let's move to next. So that's about for today's video. Thank you for watching. and we will discuss more questions in next chapter 5. Until now, happy learning. Thank you for watching again.